In this part of the video, we'll go over the container assembly, the parts, and the functionality. So here are the four main parts of the container. Here's the base of the container, which acts as a dispensing mechanism. And here's the volumetric slider. And the whole of the slider is equivalent to 1/4 teaspoon of volume. The slider goes into the base like this. And when the linear actuator pushes the slider, both the holes align and the spices fall out through the bottom. A spring goes over here, which pushes the slider back into its original position. The bottom of the container contains a cutout through which the spring can be cleaned easily. Here we have the main body of the container, which has a curved surface on the inside that acts as a funnel to concentrate all the spice towards that hole at the bottom. So the main body goes over the base like this. And as a final step, we have the lid that goes on the top like this. So full container assembly is complete. Here we have a small demonstration of how the dispensing mechanism works. So we have this small piece prototype which houses some spice, shows the inside of the funnel shape of the container, and as you can see, as the slider is being pushed, the spices fall out from the bottom, filling the bowl below.
Alright, so now we're going to do a brief electronic overview for the device. So right on top of this 3D printed tower, we have a limit switch. This limit switch is responsible for detecting if the lid has been placed on top. If the lid is absent, then it will not allow the device to dispense anything, and nothing will move, and this is to provide some user safety. Underneath that tower, we have a couple of wires leading to the 3 photoresistors that are used for level sensing, as well as the LED. They're located about there. Then underneath that, we have our 5-volt linear actuator, which dispenses the spices. Going back to the overhead view, we have our 2 stepper motors. These are responsible for moving the carousel and positioning it correctly. And while they have 2 differently colored gears, they are functionally the same. Underneath the stepper motor with the white gear on it, we have a circuit board. The circuit board contains a couple of pull-down resistors that are used to allow the photoresistor circuit to work properly. And then in the blue box on the right, we have our ribbon cable leading to the touchscreen display. Back to the overhead view, we have our LM317 voltage regulator. This is responsible for changing the 12-volt power supply to 5 volts for the linear actuator. And it's in a 3D printed case just to keep any shorts from occurring. Now in red we have our Arduino stack, which we'll get a closer look at in just a moment. So underneath our Arduino motor shield, which drives both stepper motors, we have an Arduino Uno. And then on top of that shield, we have a proprietary display driver shield that's used for the touchscreen. Then on the left in the blue box, we have our fuse holder, which has a 12-volt 3-amp fuse in it to prevent any shorts, any overloads of the power supply, and also just to protect the electronics. And then finally, we have some of our power connections. They're using lever nuts to bring the 12 volts from the power supply that's connected with a barrel plug externally to the motor shield. And then this is an external view. On the left in that silver port is where the power supply gets connected. It's a barrel plug connection. Then underneath that we have a master power switch, which is used to cut power to the device in case it's needed. Then on the right we have our fan grill, which protects users from the 12-volt fan that we're using to cool one of the stepper motors. That's about it.
The programming aspect of this device consists of two different codes, 4DGL, which is a graphical language that the LCD display uses, and C++, which the Arduino microcontroller uses. The 4DGL code was created on the Workshop 4 platform and was used to create a graphical user interface. Each toggleable button is designed to do a certain task. For example, clicking a single splice button changes the page on the screen to form 1. The C++ code was written on the Arduino IDE and communicates with the 4DGL code to complete tasks. It includes 3 different libraries to interface with the electronics correctly and use arrays to store data that is to be displayed on the LCD screen. The way that it works is that the program constantly scans for whether a button has been pressed on the immediate page and then calls a void function. The device consists of default spices for each slot, which can be changed to different spices using the setup function. For demonstration purposes, the first 4 slots will be changed to black pepper. Spices 1 to 4 are now labeled black pepper. The spice leveling function determines the approximate amount of spice that remains in the container after a dispensing command. A half-filled container is used for demonstration. Selecting spice levels, it can be seen that the container for paprika is 50% full. The same is done for a container with the following amount of spice. The spice level now appears as 25%, alerting the user that the container is near empty. The device consists of a feedback loop that prevents any dispensing action when the lid is removed. As seen on the LCD display, the words "lid is removed" alerts the user that the lid must be put back on. After the lid is put back on, the user can resume the functions of the device.
Alright, so now we're going to test the dispensing functionality of the device. We're going to dispense half a teaspoon. Going to pour it into a measuring cup to verify. This is a half a teaspoon measuring cup, so it should be nearly full. Well, it looks like it is, so good to go.
In this video, it shows how the device's lid and containers inside can be easily and quickly removed and put back together. It is important to mention that just the container removal and refill takes 15 seconds, but we decided we want to take the demonstration a step further, so we recorded the entire process, which takes 25 seconds. This allows the user to be able to quickly add more spice to finish their recipe.
Here we see how the containers are washed. Here we have a very dirty container that was pre-filled with paprika, and paprika is a very grainy and very sticky spice. Always gets stuck in the ridges of the 3D printing layers. So here we see we rinse it out, just a simple wash with water, and pretty much washes all the paprika out inside from the dispensing mechanism, from the spring, and from the container itself. And here we can see the results. Pretty clean. Here in this lifting test, with the device being under 15 pounds, it is fairly easy and safe to mount the device on the underside of the cabinet or shelf, which are depicted by this wooden plank.